Welcome. We're going to go through the chapter 6, assignment number 1. Here we go. First question is rolling 2 dice like we did in class last chapter, and then you add them up. They say that T is going to be the sum of the dice. So T is in the table, and then I've got the probability of T. So the lowest you can get on 2 dice is 1 and a 1. The most you can get is a 6 and a 6 that make a 12. And then you may wonder where I got these probabilities from. We learned last chapter 7s are the most common, and like 2s and 12s are the least common. I copied and pasted this table from last chapter, but like here's the 7s right across this diagonal right here. There's 1, 2, 3, 4, 5, 6 ways to roll a 7. How about 4s? 4s are right here. 1, 2, 3 ways to get a 4, and so on. So that's where I got this table, this probability distribution from. Making a histogram of it, not that complicated. I just put, the sum of the dice on the bottom, the frequency on the side, and there you go. C, what's the probability that T, and what is T? T is this, okay? So what's the probability you get 5 or more? So that would be 5 or more is all of these. So that includes 5, 6, 7, 8, 9, 10, 11, and 12. So if you add all of those up, you're going to get 30 in the numerator. So 30 out of 36. 6, new story here. The probability of someone aged 19 to 25, how often they work out. A lot of people said 0 days a week. So that's 68% of the people don't work out at all. Here's a 4 days a week. That means 5% of people work out 4 days a week. You can see that as you get up to 5, 6, and 7 days, these are pretty low. Okay. To show it's a legitimate probability distribution, you simply have to add all of these up, like I did right here, and you have to show me that it equals 1.0, which is 100%. And it does. Making a probability distribution again. This time I put the percents on the side because that is what I was given. Up and days on the bottom, percents on the side. 68% is far larger than all of these, so it makes sense that you have this really tall bar at the beginning. You could say that this would be skewed heavily to the right. Letter C, describe the event y is less than 7. Y is the number of days you work out, okay? So this would be the probability someone works out less than 7. This is a less than symbol. So really, that would be all of these. Or another way to think of it is if it's all of these, well, it's everything but the 2%. So 100 minus 2% is 98%. D, working out at least once. Here's the notation. At least is greater than or equal to. So y, again, y is the number of days. It has to be at least 1. So that would mean like 1, 2, 3, 4, 5, 6, or 7. So it's all of these, okay? But what I chose to do, and you can see, is I just did 1 minus what I don't want. I did 1 minus the probability of 0 days. So you get 32%. 8. We have 2 events related to this chart. So event A is working out at least once a week. Event B is you work out less than 5 times a week. So what outcomes make up event A? A is made up of working out at least once. So 1, 2, 3, 4, 5, 6, or 7 days. Okay, which is in fact what he did right here, really. Okay. B is made up of less than 5 times a week. So that would be 0, 1, 2, 3, and 4. 0, 1, 2, 3, or 4 times a week. The probability of B is to add these up, like I did right here. And I got 93%. C, what outcomes make up the event A and B? So remember, A and B means you want both to happen, okay? This works out when this occurs when someone works out at least once and less than 5 times. So that would be once, twice, 3 times, or 4 times. These are the 4 outcomes that satisfy both of these things. And then you find them in the table and add them up and you get 25. Here's notation again. The probability that y is greater than or equal to 1 and less than 5. This would be like the probability of A and B would be, I guess, another way you might think of it, A and B, like that. Next, this is the number of cars that are in a household. You can see the most common answer is 1 car at 36%. 35% of homes had 2 cars. A housing company builds houses with 2 garages. What percent of households have more cars than what this garage can hold? So it's asking you for more than 2. So adding up these 3, which is D when you add, or B when you add those up. What's the expected number? Okay, here we go. This is when you take each outcome times its probability. So 0 times 0.09, and then 1 times 0.36, and then 2 times 0.35, and so on. And you do that for all of these outcomes, and then add them all up. This is the symbol for expected value, expected E, okay? And just take your time on the calculator. Very easy to type in something wrong, and then maybe you would get D if you're not careful. But it comes out to be C when you put all that in. You can also think of this as the average. The expected value is the average. Number 2. This is an FRQ that you might see. This is talking about a company that's considering buying 2 different machines. Okay, photocopy machines. Yep, machine A and machine B. They replace photocopy machines every 3 years. Okay, and then they have to repair these machines. Okay, so the repair to fix machine A is $50 every month. So they just pay like a monthly fee, $50 in January, $50 in February, in March, and so on. And that covers unlimited number of repairs. But the repair for the machine B is different. They pay $200 per repair. If it doesn't break, they never pay for a repair, so they never pay anything. If it breaks a whole bunch, they pay $200 every time. And then this is the table that, based on past performance, this is the number of repairs that will be needed over a 1-year period for machine B. So, for example, right here means that 25% of the time you will have 1 repair that year. 10% of the time you'll need 3 repairs. Okay. I don't know why I did this. Why did I say a van? They're not vans. It's a machine. A machine is replaced every 3 years. So we use that as our framework, okay? We're going to give a recommendation as to which machine, A or B, including the repairs, should be purchased. So, what am I doing with vans? Machine A. Okay. Machine B. Okay. Anyway, so machine A is it costs $10,000 off the get-go, so that's my 10,000. Plus, it's $50 per month, okay, for 3 years because it takes 3 years to repair or until they buy new ones. So I did $50 a month times 36 months because that's 3 years and months. So when they buy machine A, they know they're going to spend exactly 11,800. Okay. Um, Machine B is going to be different. There's my machine thing. Come on. Machine B, okay, um, is going to be, it's more expensive. It's 10,500 based on sorry, right here, plus repairs. But the repairs are a little bit up in the air because you pay per repair. So what we're going to do is find how many repairs would be average or expected. And I'm doing that right here. Expected repairs for van B in a year. Okay. Um, and I've got, again, 0 times 0.50, 1 times 0.25, and so on for all four of these. And then you add them up and you get 0.85 repairs. So this is repairs per year. But again, you expect to have this machine for 3 years. So we're going to triple that to get an average of 2.55 repairs every 3 years. Okay. And for machine B, you pay per repair. You pay $200 per repair, and you have, again, 2.55 repairs on average. Okay. And that's all you can do is make your best guess on what the average is going to be. You take the original cost of the machine plus the cost of the repairs, and you're going to get $11,010. So here's the total cost of each machine. Um, and I got to get rid of these. This is really bothering me. Machine B, machine A. Okay. So machine B will be cheaper. How much cheaper? $790. Take this minus this, and you get $790. All right, that's the end of the first lesson.